Greetings to all you exquisitely inquisitive ladies, gentlemen, and scholars, and welcome to Natural Philosophy with J. Allen. Today, we will be learning about the velocity problem again, whereas before, we were learning about the average velocity. Today, we will be learning about instantaneous velocity. Oh, and how exciting that will be. Right, so this is the problem that we were seeing before when we were using average velocity. Now today, we're going to be using instantaneous velocity. So if a ball is thrown into the air with a velocity of 40 feet per second, its height in feet t seconds later is given by the formula f of t equals 40t minus 16t squared. So, estimate the instantaneous velocity when t equals 2. Right, so again, we're going to be using limits today, whereas before, we were using limits in a theoretical manner, showing it pictorially through a graph. Today, we will be using actual math, calculus, with our limits. So, let's see how it works, shall we? Here we are, so this is the slope of a curve formula that we derived from the very first episode. So this is the distance traveled over time. And since for this particular problem, we want instantaneous time, we want instantaneous velocity. So this h is ever approaching 0 seconds. So it's never going to get to 0, but it's approaching 0 because we want the exact moment of time that we want a particular exact moment in time, and that particular exact moment in time is 2 seconds. So we want our distance traveled to kind of collapse in on itself in a sense and be 0 seconds, 0 amount of time traveling, you see. So that h is going to be becoming infinitesimally small. It's not going to quite reach 0, but it's going to get so close to 0 that you can't even tell that it's not 0. To us, it'll look like 0, but to the actual h traveling, it actually will feel like it's taking an infinite amount of time to actually reach 0. So that's how you would explain that. And so what we want is to evaluate this side of the equation first. So what we're going to do is we have f of t sub 0 plus h, and our initial time is 2. Our initial time and our concluding time is all 2. It's all one instantaneous time. So we'll plug 2 into the t sub 0. So we get f of 2 plus h, and we want to plug f of 2 plus h into this equation here. So we plug 2 plus h into that t, and we plug 2 plus h into that t. And then we would plug that equation into this side of the formula. Next, we want to evaluate this side of the formula. So we would plug f of 2, or just 2, into this equation here. So we'd have 40 times 2 minus 16 times 2 squared. And so let's look to see what that'll all look like after we plug everything in. So I'm going to erase the board now so that we have room to work. Right, so here we have what it would look like with everything plugged in. So, like I said, we worked with the left side of the equation, and we plugged the 2 plus h into that equation there. So we plug the 2 plus h into the t, and then we plug 2 plus h into that t, and that's what it looks like for the left side of the equation. And then we just simply plug t sub 0, 2 into t sub 0. So, and then we plug that 2 into those t's, and then we would take that equation and plug the whole thing into the right side. So off camera, I decided to go ahead and work out some of this for us. 40 times 2 is 80, and then 40 times h equals 40h, and then we have the negative 16, and I foiled all that for us. So we have negative 16 times 4 plus 4h plus h squared. And then when we distribute all of this, when we distribute this negative 16 into the 4s and everything, we get negative 64 minus 64h minus 16h squared. And then you can do some more canceling out, and we get 16 minus 24h minus 16h squared. And over here, it's a lot simpler. All we had to do was do 40 times 2, which is 80, and 16 times 4, 2 squared is 4, so 16 times 4 equals 80 minus 64, and that equals 16. So now we'll combine all of this together. Right, so we still have the left side and we have the right side. So we have f of t equals the limit of f of t equals the limit as h approaches 0 of 16 minus 24 minus 16h squared minus 16 all over h. And so we can see that the 16s cancel out because 16 minus 16 is 0. So the 16s cancel out and we're left with this. The limit as h approaches 0 of negative 24h minus 16h squared all over h. And so what we could do here is we see that we have two h's in our polynomial. So we can factor out an h. And so we have here the limit as h approaches 0 of h times negative 24 minus 16h all over h. And now we can see that we can cross out these h's. These h's here cancel out. They just multiply out of it. So now we're left with the limit of h, the limit as h approaches 0 of negative 24 minus 16h. And what we can do here is something like plugging a 0 into the h. We're not actually plugging 0 into h because h never never definitely reaches 0, as I've said before. And we could never have put the 0 into the h before, because if we had a 0 on the bottom of our denominator, then that just causes problems, as everyone knows. So now we can plug the 0 in. I say plug 0 in, but we're not actually plugging 0 in. We're plugging an approximation of 0, you could say, into the h. So when you plug 0 into h, you get negative 16 times 0, which is 0. And we're left with instantaneous velocity equals negative 24. So that we're traveling at negative 24 feet per second at that particular time, which the time was 2 seconds. So that's what that means. The instantaneous velocity is negative 24 feet per second at 2 seconds. And that's how you do instantaneous velocity. Thank you so much for viewing the show. I'm not quite sure what we'll have for next week, so it'll be a surprise for the both of us. I do hope you'll make it. Thank you.